Hey everybody, this is Roto Motion and Douglas GB doing Season 1, Episode 7. Just before we start, want to give you a little bit of feedback, or I guess response to your feedback on size of the screen. If you notice, we were able to get the FPGA catbox screen about a third larger. So just listening to your feedback, appreciate the comments that you guys have given. Helps us get better each time. So I have to tell you, super excited about this particular episode. This is an advanced episode. We're going to be getting into specifically tracing signals. Now, the reason I'm so excited about this particular episode is Douglas is going to guide us through how to trace signals on a vector board and actually set that up so that the next episode we will actually go through acquiring those signals for the purpose of tracing things that normally you would not be able to do because the vector section is separated from what the CPU can reach. So without further ado, Douglas, take us into episode 7.
Yeah, that's a great introduction because the state machine has always been kind of a very tricky thing to troubleshoot because of this nature right here where it kind of feeds back into itself. So if it's working, great, but if it's not working, it's kind of a loop that where do you start? so so yeah, that's what the as you said, the tr- vector generator test tab of Fred's tester, and then now this continues to be developed and there's more and more stuff added to it. Trace setup is is when you go and probe different parts of the state machine, and the tester will kind of the tester and some of the test scripts that is up to the community to develop, um, will know what the data should be. So if you're going around probing what your trace is telling you to probe, it's similar to signature analysis, but not quite. It, it works in a like there's a different stimulus, compared to signature analysis, but the overall concept is the same, where you're gathering the activity on any of these given lines in the state machine and comparing them with what they should be for in a given state. So yeah, let's just get into it. It'll hopefully get clearer as we go. To do that, you need to first know, well, what board am I working on? Because although the state machines are very, very similar throughout all the Atari vector games, the chip locations may be different. So the first thing is, in fact, go back to setup and load the config for the board you're working on. So we're going to call up our old favorite space tool. So you can see it has not only memory addresses for commands like vggo, but also it has this is version 2.02, which is the current version as of today, March 7th, current released version. It has these memory addresses. It also has the chip locations for some of these chips. Like you can see, OP0, 1, and 2 are on chip N4, and that's what they're the signals. OP0 comes in on N4 pin 3. So that is all in the board setup file, so it saves you from having to put that in. So load the config before you head over to vector generator test. And then when you do, we kind of did standard test before, but this is all about trace setup. So to do that, well, you need a program. What are you going to trace? There are some that come with it. We're going to use the same one as episode 6, this halt only test. And when you load that, you can see it brings in this whole box of things that it's going to show you, this column of things that it's going to have you gather the signals for, and then over here is the vector program that runs to make those signals. Our clock pin has been populated because we loaded the board config. So R4 pin 9. Here's R4, there's pin 9, and that is the clock. So yeah, it's all it's in the combination of the INI file and the trace setup file. And you can develop more of these trace programs. Yes.
Douglas, can I ask you some questions just to clarify for our listeners? So you're basically saying we need to take the clock and physically connect it to the pin 9 on R4, right?
Yes. Yeah, that's a good point, because of course you have this clock here, which is the main clock if you're doing RAM and ROM tests and all kind of other tests on the board. But the vector generator, because it's its own little part of the board, this clock pin is the vector clock. Or
yeah,
so
make sure you actually connect your right to R4 pin 9. You actually physically connect to that pin to get the clock for this.
Right, and yeah, these are the connections that it's asking you to make. So whereas before you may not have used the BNC connectors of the tester, because you can have it, if you're doing signature analysis, you can have it get stuff through the ribbon cable, but again, the CPU can't reach all the way into the vector state machine, so you need to use those BNC connectors. So it tells you start gets connected to the halt test point, and then clock, the BNC connector on the tester, you need either an oscilloscope probe, or they make cables that have a BNC on one end and two little hook connectors on the other. One would be ground, and then the red one would go, as John said, to pin 9 of the state machine flip-flop. What is the state machine flip-flop? LS174. Well, it tells you. It's R4. In the case of Space Duel, R4, and then pin 9. So yeah, it's a different physical connection. Start, clock, stop is connected to start, so you don't need to hook that up to anything.
Now, I saw that you instructed everybody to actually load, and you chose the program halt, which makes sense if you're going to be testing why your halt doesn't work.
Mm-hmm. Right, yeah, there are other programs that you can load, and more will be developed and released. So there's going to be, I think, a GitHub repository where you can get all this kind of stuff and contribute to it, which will be great. But yeah, these tests are because again, the vector state machine, if it's working, then great. But if it's not working, then you need a bunch of different tests that are going to exercise different parts of it, so that you can narrow down which part of it is not working. And halt is like the first one to do because it's the simplest one. And then you build on that. So that's why we did in the previous episode, that's why we did the halt test first. And that's why we're doing it again here with a little more explanation. So again, the halt test, it's gonna, we're not gonna measure a whole lot of things because the halt is very basic. The only signals we need to trace are the what are there, like a dozen or so in this column. The OP, which stands for opcode, that's the actual command that the state machine is trying to execute, and the command is halt. These 3 bits in Atari vector generating programming language, these 3 bits define the command, and then F0 through 3, you can see on the schematic are these kind of feedback lines that come back into the state machine that tell it where it was, so it knows where to go next. State 0 through 3 are kind of the outputs of the vector prom, and then there are a couple more go A. It's called go A because it's not really go. This is go, official go signal, and it goes through this gate, and so this signal Atari never labeled, so Fred just calls it go A, and that goes into pin 15. So this column will vary depending on what test you've loaded. For halt, again, it's just these very basic ones, and you can see they're centered really all around N4. In fact, that may be that they are, I think they're all the pins of N4 and nothing else, because that's by comparing what's coming in on the input side and then what's going out, this will be able to gather enough of a picture to tell you, oh yeah, your inputs are good, and when your inputs are this, your outputs should be this. They are? Okay, great. And then it changes the inputs and compares the output, and it goes through that for the whole sequence that is halt. And if it's good, then great. If it's not, then you'll see that when you go further, when you have to, this is the setup, then you do the acquire, and then you view the results. And that is what all these different signals do when it's trying to execute a halt command.
So Douglas, back on the trace setup, I noticed that there's those clock slope switches. Do I need to adjust those at all, or those come directly from what I loaded?
Those, they will be set according to the program that you loaded.
Okay.
So yeah, the polarity, trace count is not something you set. That actually shows you how many cycles the test takes to run. And we'll be able to see that when we look at the the results. The vector generator type will come with from the INI file. Reset before trace, that's a good idea in case your vector state machine is not working, which is why you're here. It will reset it before it tries to have you gather the trace.
Can you cover one more thing, Douglas? The save reference button.
Yeah, that is used mostly when you're developing the test. It records the known good results for the things you're tracing. So these signals that you're tracing, when you acquire them, you can see the reference light is lit up. That means that this test includes those good values when the test was created, and you want to save them save them when you save the test. If most people will just be using the test, so it won't matter, but I would leave it turned on. The signal, we have not gathered any so far, so the signal lights are not lit up, but when you actually were to start acquiring them, then those signals would light up and you could compare them to the reference signals. So just keep in mind that a green signal light doesn't necessarily mean good, it just means that the signal has been captured. Back in time trace, you can see those 4 cycles, 0, 1, 2, 3, and you can see your data. You can choose how to, back here, you can choose how to group the different signals and how to display them. I think we'll go into that in another episode.
So in episode 8, we will go into trace acquisition tab, and it took us a while to get this trace setup tab working the way we wanted it. So feel free to practice this a couple times before you move on to episode 8. But that is episode 7, everybody. We will see you back for season 1, episode 8, coming soon. See you later.